Hi, welcome to System Designer. System design is a product of my background, which includes various roles in first engineering, then education. I moved into education thinking, how hard can it be to teach the electronics and digital technologies that I loved working with? Well, education proved to me to be a bit of a quantum problem, both hard and easy at the same time. Students love making things, but also struggled with some challenges of understanding. My response to this was System Designer. I designed and developed this to help new learners build the mental model of an embedded system they need to succeed. In education, we call this a notional machine, a way of thinking and modeling in our mind that helps us know how a computer is doing what it is doing. I start with a systems approach. Think of this simple pedestrian crossing system here as a system which solves the issue of getting pedestrians across a busy road safely. It has both hardware and software. Again, this is a quantum issue. A system is an entanglement of both hardware and software at the same time. And in system design, students can design a system and code that system and run it at the same time so that they can see the entanglement and begin to make sense of it. Let's run this code line by line. I can step through my code, and what it's going to do is it's going to run this setup function once. And then it's going to go through my loop function and run that continuously. So I'll just step through this line by line by line by line by line. Right, and you can see as each line happens, something happens. At the moment, well, you're thinking about the setup code runs once when the power is turned on. So that means when the power is turned on at our pedestrian crossing, what state do we want our lights to be in? We want the green light for the cars to go. That would make sense, otherwise the drivers would get confused, and we want all the other LEDs, the lights, to be off. Okay? Then it goes into the loop program, the loop function, and it steps through all the lines of code here, and you can see it's actually running only 2 lines of code at the moment, and that's because it's doing a read of this switch and storing its value in memory. And then it's checking to see if the value in memory is 0 or not. And at the moment, let's just have a look at our zeros and ones because we can see them on the system. Logic 1 is here, okay? That means that our switch is not pressed. And when we press it, it goes to 0. And we use this reverse logic, okay, in computing with microcontrollers and embedded systems. It's pretty common to use it this way so that when we press it, it goes to 0, and when we release it, it goes to 1, okay? And as you can see here, the LEDs are off except for this one, which is a logic 1, and the LED is on, okay? So what's happening down here is it's reading the value or the level, logic 0 or 1, and storing its represented number in memory. So let's have a look at the variables over here. And there's the value stored in memory. So let's make this a little bit bigger, right? There we go. So if you can't see all these, you can actually drag these around a bit to make them a bit bigger. Best to do that while the program's not running. So at the moment, we've got a hex value of 1, a binary value of 0, 0, 0, 0, 0, 0, 0, etc., 1, which is a decimal 1, which means it is. But when I press this, you'll see it doesn't go to 0. Now that's because there's a line of code in the program that does that, and it's already executed that line of code. So I need to keep stepping my program through until it gets back to that line of code again. And when it reads this line of code over here on the right hand side and does the read and stores the value in memory, it's going to look to see what this is 0 or 1, and it's going to store 0 in here. So when I go step, there we go, it's stored 0 in here. The pin has gone to 0, the input circuit has been detected as a logic 0, and that is stored as 0 in memory. And if I release the switch again, it's now going to still keep that 0 stored in memory because it's already read it. It won't change that value until it gets back to here again. So let's just step through this. If the value is 0, then do something with the lights. Okay, so this is a really good thing here for students. This program's not complete yet, and I do this with students. I get them to finish the program, and they can do this without understanding too much about the syntax and getting hung up on its difficulties. They can just do this. So let's have a look. First of all, it turns on the pedestrians, tell them don't cross yet. Okay, that's what it's saying to the pedestrians, don't cross yet. Okay, Now, because the next thing it's got to do then is turn on the orange LED. And you'll notice that when I turn on the orange LED, the green LED's still on, so I have to turn it off. Okay, and this is the first and most fundamental sort of concept in programming embedded systems, is that nothing changes until you tell it to change. Okay, it's got a state, right? And things have to be done in the right sequence as well, and the states have to be changed in the right sequence. So now we've got a good sequence, okay? And the next thing we're going to do is we're going to wait for a while, because of course cars need a time to stop. Now I've put in 10 seconds there, delay 10. This is a really good thing I do with students, is actually say, well, how long should this be? And get them as a homework exercise to actually go and time a set of traffic lights and get them to write down the sequence really, really clearly, so that then we can translate it into code. And coding's simple because actually we've got all the code in front of us on the screen. All we have to do is copy the bits we need and change the specialist bits. So what's going to happen now is it's going to wait for the cars drivers to see that the light's gone orange, give them time to stop, and then the next thing that's going to happen is the orange light's going to go off and the red light's going to come on. Okay, and then we're going to have a short delay. Why do we have a short delay after the red light? And you can see the thinking here. Students can start thinking from the system's point of view immediately. They don't have to think about code, which is just a tool to actually help them develop a system. They can think about the system. And so why do we give a little short break between the light goes red and the pedestrians getting their green cross? Well, that's for the red light jumpers, okay? So we want to make sure that pedestrians don't start crossing immediately the light's gone red, because there's a few drivers who like to push the red light a bit, okay? I would never do that myself. Okay, next thing here is we turn on the cross LED for the pedestrians, and we turn off the don't cross LED for the pedestrians, and then we wait for a while for pedestrians. Again, now this is where it's really good for students to think about, well, how long should this system be? How long should my timing be? And then the next thing I do is I ask them a question, what happens next in the system? Because I haven't put the code in down here. I haven't put the code in for them. What I want them to do is figure out that actually what happens next is that after a while, the cross LED goes off and the don't cross LED flashes a bit. How many times does it flash and how long does it flash for? And this is the systems thinking that we can get into students immediately when they start writing a program for the first time. They've never seen a piece of code before, and they can do this. Okay? It's not hard. And the reason they can do this is because I've put in here all the code that they need to turn on and off the LEDs, right? And the code is automatically generated for reading the switch. Let's see how that happens. System Designer comes as a blank slate with a few instructions here, trivial instructions, and then a bunch of devices. So what we've got here is we've got Uno and Nanos programmed in C, and we've got Unos and Nanos programmed in Arduino C. There's a subtle difference between the two. The Arduino C is a bit of a simplified version. If you're going to be programming and using Atmel Studio, then you can use some of these other C-based programs. Or if you're actually using the ESP32's cool devices, you can program them in Arduino C. Now you'll see that the moment we put our microcontroller into the designer, we've got our boilerplate code just appeared here. We don't have to worry about telling students what to do. And now I want a red LED. Okay, I'm going to put my LED over here. This is called LED 1. I'm going to make it a little bit bigger so you can see it. I'm going to double click on it and I'm going to change this to red LED. Okay, and there we go. And I use capitals for this. Right, so there's red LED. That's cool. Now I need to connect it to a pin of the microcontroller, and I could connect it to pin 10. Now if you hover over 10 here, you'll see at these inputs and outputs that there's a little faint square appears, and you can just draw from that to the LED. And when I do that, the code for the LED appears on the right hand side automatically. So students don't have to worry too much about this at this stage. You can build that explanations in as you go as they become more comfortable with the code. Okay, and the first thing that needs to happen here is we design a macro to say, hey, red LED pin is the name of this pin here. It's actually 11. So red LED pin is how humans are going to refer to this, but 11 is how the microcontroller is going to refer to it. And you'll see in our program that when I run our program, these commands actually change to the values when I step it. If you watch all these values here change. So the computer, the microcontroller, doesn't know what read left pin is. It knows what 12 is. And when we run our code into a microcontroller, it just changes these automatically. The reason we use this macro to represent 12 is because it makes our program so much easier to read. Imagine if you were turning on and off 12s and 11s and 9s and 13s down here instead of don't cross and orange lead and green lead. It'd be impossible to understand. So go back to our designer. So what we've got here is that, and the first thing we need to do is to tell our microcontroller that this pin 11 is an output pin, okay? And that's what this line of code does here. And this goes into our setup code, which runs once. I'm going to put another LED in for the moment just to show you that process again. Make it a little bit bigger to make it clearer. Double click to change the name to orange underscore LED. I don't need a plus in there. Don't put an enter in here, it mucks everything up. Okay, and there's our orange LED. It's a little bit bigger than the red one. I can make the big red one just a little bit bigger. There we go. Now, you'll notice that this is connected to 11. I'm going to change that to 12. And when I do this, it automatically updates the code on the right-hand side. So that changed from 11 to 12. So I'm going to connect 10 to the orange LED. Okay, I've got 10 over here on the right-hand side. Let's make this code a bit bigger so that we can see it a bit more clearly on the screen. It's 10. I'm going to change that to 11. Okay, that's cool. So there we go. Here is our system being designed for students automatically. They design the system and the code appears. They don't get hung up on all this stuff. Now, of course, a pedestrian crossing needs a switch, and I'm going to call this PED switch. PED switch. We like to use good names for things in coding, and often I'll use a full name for something like this if it's going to be at all complex, okay? So I'm going to hover over this now. Just deselect it, hover over it, and start to draw the line, and you can take it to the pins that you want to use, okay? Now, some of these pins you can't connect to. Only ones that are I/O pins can you connect to. So I've connected it to 13, and this is where our code has done an automatic update for us over here. We've now got everything we need to do this. In fact, here's our memory allocation. We can see what's happening, our variables won't appear until we run the program. It's at a binary 1 at the moment. When I click on it, it goes to 0 because that's what happened. Okay, but when I run the program, of course, what's going to happen is it's going to read this pin value and write it into memory over here on the left-hand side. Make it 0, goes to 0. And every time it reads that line of code. So this is a bit of a brief introduction to the AppMouse System Designer. There are more devices over here, which I'll get to in later things, okay? Analog to digital conversion, and a few other sort of basic sort of blocks that we, if you wanted to connect this to a solenoid and say, solenoid for the door or something, right? There we go, we've got a solenoid for a door. And it's just, and I can change the color to blue for this. So this is an introduction to System Designer. Maybe I'll do another video soon adding some more stuff to this. Cool, thank you.